The concrete block A of mass m is used to pull the 200 kilogram log B up to the ramp theta, arc tangent 3/4. Given that the surface of contact between the log and ramp is very smooth and the mass of the block A is 125 kilogram, determine the acceleration of log B after it is released from rest, and B, determine the tension in the cable. What happens if the surface of contact is rough? For example, mu equal to 0.2. Explain. Okay, you have a log, it can move upward or downward, and then you have a block A. You have one cable connected to B, but you have two cables connected to A. So assumption here, one is smooth surface, no effect of friction. Mass of the rope and pulley is negligible. Friction in the pulleys is also negligible, and no air resistance. We start with kinematic equation. Kinematic equation, we don't need free body diagram. Free body diagram is about force. Kinematic is not about force. When we have pulleys and mass, we start with the length of the cable. Put a convention. Which direction is positive? I will say that positive downward and positive incline. I put the origin is this pulley. SA will be directed downward, positive. SB is directed to the left downward, positive as well. We have 2XA plus SB, constant. And then you differentiate to SA dot plus SB dot equal to 0. 0 because constant, if you differentiate with respect to time, is 0. So that is the velocity. And then you differentiate again to obtain acceleration. 2SA dot plus SB dot equal to 0. Or, and then I put AA equal to negative AB over 2. Having the kinematic equations, we go to the next step, which is the kinetic. For that kinetic, you have to do free body diagram. But we are going to focus on the body only. To body A and body B. Block A has a weight downward. It has two cables above the pulley. The tension in the cable above A, one cable, but this one cable connected to two cables. So it is equal to 2T. No other force. Now let's see block B. Block B has a weight vertically downward, passing through the center of gravity. And then we have a normal perpendicular to the floor. We have one cable connected, so that will be a T. If there is friction, there will be another one in the contact between the log and the floor. If it moves to the left, then the friction is going up. But in this case, we don't have friction. The contact is very smooth. So these are the three forces. So having this, we are going to write the equation sigma F. Sigma F for block A, assume that positive downward, equal to WA minus 2T. WA is MA times G. So you can replace WA with MAG. You have that one. Okay, now let's see the free body diagram of log B. Here we are going to project the weight to the axis parallel to the floor and perpendicular. So in the axis parallel to the floor, it will be this with the value WB sine theta. In the axis normal to the floor, it will be WB cosine theta. If you have theta here, the theta will be there. In the direction of ramp, it is going to the left downward, positive. I have WB sine theta minus T. In the direction normal to the ramp, it is in this direction, WB cosine theta minus N. But that one is equal to 0. Why? Because we have floor. The motion in this direction doesn't exist. So it means we have static equilibrium in this direction. So we are not interested to that part. So you put WBMGG have the expression of sigma F in the direction parallel to the ramp. Now we write the kinetic diagram. Block A, we assume that the acceleration is in the positive direction, so going down, MA, A. And then in B, again, I put convention positive downward to the left, so you have MB, AB. The previous sigma F, the MA for block A. For block B, the previous sigma F and MA for block B. I take the expression of AB equal to 40 minus 2 MAG over MA, and then I replace inside this. So I have this expression. So you have the expression of T. You obtain the values of T. The tension on the cable, 689.35 Newton. Now you want to obtain the value of the acceleration. You have the expression from equation number 6. You put the values, you obtain AB. Positive, it means it is directed downward to the left following the ramp. The value of AA, which is half of AB, and then negative direction, it means AA is going up, this one going down. What happens if the surface of contact is rough? For example, mu equal to 0, 2. If we assume that the block is moving downward, there will be friction going upward, Fk. K is kinetic friction, because we know that friction got static friction, kinetic friction. Static is when it is not moving. Once it is moving, it becomes kinetic. If the contact surface between log B and the ramp is rough, there will be friction force created at the contact surface in the direction opposite to the motion. The formula you have studied in static, Fk equal to mu k times n. N is the normal force, mu k is the friction coefficient. K means kinetic. Usually the value of kinetic friction factor is smaller than the static. You return back to the equation of kinetic. And then I try to solve AB. This is AB, just like the previous one. You obtain the value of T. When you see, you compare this one with the previous one is up to here. Now we have additional negative mu k cosine theta. So that is from friction. From here, we notice that the value of T is reduced by the presence of friction on the contact surface. So if you put the values, you have, this is the tension when we have friction. It seems that we have reduction of 6.15% due to the friction. If you assume the friction factor is 0.2.